let's prove the first one. So in order to prove this theorem, we always have to go back to the definition. So in order to prove this, we should know what surjective means, right? So what was the surjective mean? What's the meaning of surjective? So if A and B, so every element, if F is surjective, every element of B has a corresponding element in A through F. And the same is true for G. So let's suppose F and B are both surjective. Since G is surjective, for any element in C, there is a element in B such that G of B is equal to C, right? But for this element, it's annoying. For this element, since F is surjective, there is some element in A, let's call it A, such that F of A is equal to B. Oh. Okay. So that means if we map this A by F and then mapping this element by G, we get C, right? So from this we have G of F, G of B is equal to C. But from here we have F of A equal to B. So replacing this B by this, we have G F A equal to C. But this was the definition of G after F, right? So that means for every element in C, there is an element in A such that G after F of A is equal to C. So that means this mapping is surjective. Okay. So the rest is exercise. So you should prove part 2 and part 3. But if you can prove part 2, part 3 should be easy. So always go back to the definition. Okay. Any questions? Okay, let's see this example. So let's say we have 3 sets, A, B, and C. And we define 2 mappings F and G by this and this. Then we have this diagram. So we should write A, B, C, D, and B, 1, 2, 3, and C, P, Q, R, S. Okay, so A, 1, oh, C, 1, 2, 3. It's A, B, C, D. So A goes to 1, B goes to 1, and C goes to 2, and D goes to 3. And this one, 1 goes to P, P, Q, R, S, and 2 goes to R, and 3 goes to R. So G after F of B is B. So F, it goes to 1, and then 1 goes to P. So this goes to P. And G after F of D, so D goes to 3 and 3 goes to R. So this. Okay. And another example. From real numbers to real numbers, f of x is sine x and g of x is x squared, and you can combine these two functions in either order, f and g or g and f. Okay, f followed by g, g followed by f. So we can define, so this will define g after f, and this will define f after g. So since the domain and codomains are the same set, so we can define both this and this. Okay? And don't get confused. In this diagram, f comes first, then comes g. But in our notation, this composite function is written g circle f. So it's kind of opposite. So g comes first, f comes next. But in our notation, this is f after g. Okay. Now, let's consider three mappings from A to B to C to D. So let's write A to B to C to D. It's ugly. Let's write A, B, C, D. So we have F, G, and H. Okay? We can compose F and G to have G after F. We can compose G and H to define H after G. Right? And we can compose this and H, G after F with H, to define, so H, G after F. And we can combine F and this, H after G, to define H after G after F. Okay? So there are actually two ways to compose three mappings. First H after G after F. Or H after G, everything after F. So are they the same mapping? So we have these two mappings. So is this actually same as this one? Or are they different? Well, they should be the same. But let's consider this example. And let's say define f as this. Oh, this is not aligned. So in this case, x is integer, okay, x squared plus 1, and g is 2 over 3 times n, and n is the set of n is a natural number, and h of t is square root of t squared plus 1, where t is a rational number. So here we have z to natural numbers to, oh, wait a minute, no, z to natural numbers to natural numbers to rational numbers to real numbers. So here, f and g and h. So we can compose first this and this, or first this and this, right? So g after f is this, and if you apply f, you get x squared plus 1, and from this we have this, okay? You know, x is integer, but it's squared here, so it's positive. So integer plus 1, positive integer plus 1 should be a natural number. So that the range of this function is a subset of natural numbers, right? So this is okay. And the result of this should be a rational number because this x is an integer. So integer plus 1 is an integer, and that is multiplied by 2 and divided by 3, so it's a rational number. It's a rational number. And then we apply h. So after applying g after g, we have this one. So we put this into h, and h is this, so we have this as a result. So square root of something may be irrational, so this is an element of real numbers. Now, so that is h after this. Now try this one. This one after f. So h after g of n, h after g of n is this by definition, and g of n is this, and h of this is this. Okay. Oh, sorry, this x should be n.